Thank you very much. It's really good to be here. I'm actually here as a proxy for Robert Clout, who I think a lot of you might know. Rob's been tied up in some US travel and caught COVID and got stuck in quarantine and missed flights and has had a bit of an ordeal, so we gave him a bit of a break, and I'm here to do his presentation for him, so let's see how I go. So I'm the 3D product manager at Aerometrex, and my background is in making 3D models of cities. I used to do this in the business I used to work with, and it was a logical transition for me to come across to Aerometrex and continue that work in the photogrammetry 3D data models that they go forward and make. And digital twins have been talked about a lot in the last couple of years as they sort of get a bit more prominent in terminology and a bit more defined. So we thought we'd run through what they mean for us, what we're seeing in the industry, and some of the advances that they've taken as they've developed and firmed up. So what is a digital twin? A digital twin is a highly complex virtual model that is the exact counterpart or twin of a physical thing. And when we talk about digital twins, that it's a broad term, and it can actually mean anything from a single asset, like a twin turbine engine. It could be a building or a bridge. It could be an entire city. And the digital twin is really determined by what you want to accomplish by it. It's a broad definition and it's a catch-all. When we talk about the types of spatial digital twins, though, we're usually talking about a set amount of geography and some of the built form and infrastructure that falls into it. Digital twins frequently tie multiple information systems together, and they allow for deeper and more meaningful data to be made available. There's another definition that I really like. It's a digital twin is a practical way to use all the data that you have. So looking more specifically then at city digital twins and spatial digital twins, let's look at what a city digital twin is used for. We've got centrally collecting of data sources. So we're bringing together weather and utility, we're bringing together public transport, road and air traffic, dozens of other Internet of Things sensors. And this is able to allow us to do lots of visualizations and give great visibility to what is happening around the city at any given time. We've got the compute aspect. I'm just going to see if I can bring my cursor over to show the area. No, looks like I can't. No cursor for me. That's all right. The blue blob on the left, the compute area. Similar to well-curated GIS platforms, city digital twins can allow you to do a lot of analysis and data analytics. But the connected nature of digital twins also lends itself to AI integration and more insights based on deep learning and machine learning by having these different data sets connected together and geospatially linked. There's lots of benefits to city digital twins in visualization. So it's able to provide a really good interface and usually a front end to a lot of the back end data, which allows you to build very meaningful communication pieces. You can tell a lot of stories by showing what the data means like in location and what sort of events are happening or what the data is actually representing from the real world. And then on the other side of the diagram, we had technology on the left hand, what sort of is basing these digital twins. On the right-hand side of the diagram, we've got operations, and those operations can be broken up into awareness. So city digital twins can be built to support a range of users within organisations by filtering down and showing different dashboards or real-time alerts. It can be used for key decision makers and supporting staff and keeping everybody engaged over accurate and real-time data. In that way, they can be used a lot for response. So fundamentally, there's a lot of information and spatial information stored in these systems, so using them for emergency response, for strategic planning in response to growth areas and urban growth areas, and leveraging those for large-scale events in certain centres like conferences or Olympic Games is another great use case of bringing all this data together and then using it as a basis for other decision making. And finally, predictions. So by analysing the data and running simulations, predictions can be formed from digital twins, and the results of those woven back into and displayed on top of that data. And in that way, it's a bit of an evolving product. The idea of the digital twin is that it's not a static snapshot of any given location, although it is formed of static data sets. The idea is that these are platforms which can be used to represent 4D data, put a timescale in and actually show the growth of an area or the evolution of development, the maintenance of certain assets as it goes through. This is another sort of schematic-y type diagram. This one's from Microsoft, and it provides an example of the type of data connections that could be integrated into a city digital twin. So we've got, sort of moving across the diagram, we've got buildings and road transport, we've got energy, renewable energy sources, so a lot of that utility type information can be fed into a digital twin platform. We've got housing, socio-economic aspects. We've got environmental sensors in terms of what's actually happening in real weather events. And all of this sort of weaves together to allow us to make better decisions and respond more quickly for better running our cities or our towns and our locations that we're all living in. I think this image also helps to show that there's usually a central data hub at the core of any of these given digital twins. This image shows specifically Microsoft's Azure digital twin system, but more broadly, this CDE or common data environment can take many forms and be built from a number of different components. And the key to success of a CDE is that it needs to be interoperable. It needs to connect as many systems and allow access from as many systems as possible. The real trap of a digital twin is that if data gets put into a vacuum and is really good inside that digital twin but is then not made accessible, well, it's not really a successful platform because it's not promoting interoperability or mass adoption of use. The idea with a digital twin is you're letting people interact with it, getting shared results from it, and having lots of different things feed back into it to build it up to more than its original form. So how do you develop a city digital twin? You've got to have a really clear understanding of your stakeholders and what they need to achieve from the system. So there's always a discovery and scope phase that goes through it. So who's going to use it? What do they need from it? What live data will it incorporate? How will it be made available? And what other systems or platforms does it need to interface with? All of these are key to making sure that you've got some bookends to originally scope. The best digital twins are ones that can grow and expand, that they're not rigid systems just set to the original scope that they're developed in. Then you've got to decide on the platform and architecture, and most businesses or organisations that are putting together these platforms, they need to make sure that they're anchoring to whatever they're built on. That might be, an Esri system or a Bentley system. Dassault and Hexagon have solutions. Skylab have a really great system of interoperable data. Terrier.js and Cesium are a very predominant player in the market. More recently, we've seen game engines and custom solutions come to the fore as well as a different way to sort of amalgamate this type of data and give visibility to it. And then once you've got the platform and architecture piece sorted, you need to then start populating it with data. And this comes in a lot of forms. Historical data is great to feed into digital twins because, again, that 4D aspect, being able to have multiple epochs or points of reference across any given location, gives you a real wealth of information to work on. But other key data sets that we find work really well in digital twins is 3D photogrammetry data, LED building models, so simplified building models, DTM and 2D orthomosaic imagery, building application, construction and development information. So this is again one of those pieces where if you're building a digital twin of a location, you don't want it to be a snapshot, you want it to be a live model that is actually kept up to date. So that means that you have to put development applications and the growth of your location back into there, or replace those original foundational data sets. And finally, other key infrastructure or capital works projects. So there's no point having a digital twin that doesn't show the new bridge that was constructed last year, because that's a key piece of the overall picture. Bringing those from those infrastructure projects and putting them inside the digital twin, there's always a wealth of design information. Making sure that investment is then returned back to a platform is key to the success. And then finally, the other piece of digital twins is, again, this live connected feed of data. So, bringing in public transport, road and air traffic, smart city sensors, so pedestrian activity, lighting, sanitation, noise impacts can all be woven in and be part of the decision-making process. And utility information, water, electricity, gas and waste. A lot of these things have sensors built into them now, and that's part of the picture of operation of these locations, giving people a dashboard or a way to visualise what's happening with those different systems at any given time helps us make better decisions about the running of them. So we'll move on then to some more practical examples. And these are not, I'm just going to keep that there for time, not necessarily fully formed digital twins, but more initially on the journey that different locations are going through for digital twins as they progress through. So the first one that I wanted to do is the Fisherman Bend digital twin platform. So in 2019, the Victorian government developed a pilot digital twin for the Fisherman Bend precinct, just south of Melbourne CBD. The project was strategically formed to support the development of an urban renewal through the precinct. It's about 5 square kilometres in size, and they predict there's going to be about 80,000 new jobs move into that precinct over the next 20 years. So there's lots of redevelopment. It's heavily industrialised at the moment, and there's some gentrification, there's some rezoning, there's lots of planning activities that has to happen there. So the digital twin was developed as a smaller study, not on a whole city scale, but on a precinct level, by the University of Melbourne, specifically the Centre for Spatial, Data, Infrastructure and Land Administration, in partnership with Land Use Victoria. And Aerometrex supplied some of the foundational data sets in some of our high-res photogrammetry data, as well as some of our LOD textured LOD building models. Some of the exploration that went into this platform involved using a variety of different platforms, but I think the one that we're seeing here is some of the ArcGIS Urban planning platform, which was also used to sort of as a trial, a live engagement piece over this area to look at what different planning scenarios meant and how they would shape the form of that particular precinct. That particular study was just that. It was an exercise of a very insular and specific location. The results of that are then going to tip into the next example, which is Digital Twin Victoria. So in July of this year, the Victorian government announced a larger digital twin initiative to be developed over the next 3 years. And that's the Digital Twin Victoria program. I'm going to play this video with sound and just run through some of the key items afterwards that we're seeing as digital twins evolve.
Are you ready to see Victoria in a whole new way? Introducing Digital Twin Victoria, a digital revolution for our built and natural environment. We are combining trillions of data points in one online space to create a digital model of Victoria. And over the next 3 years, we will be building the most comprehensive collection of rich 3D spatial data ever assembled for Victoria. It means old paper-based systems that used to take weeks, months, or even years to process can now be achieved in a matter of seconds, giving us the power to respond to our ever-changing cities and environments, and turbocharging the delivery of major building and infrastructure projects, positioning Victoria as the country's skills and innovation capital and home to Australia's most successful economy. On Digital Twin Victoria's platform, you can monitor live data, like showing renewable energy capacity from sites all over the state. It can even harness the power of other applications, like our new e-Comply tool, so you can get on with your build quicker. Digital Twin Victoria will offer unprecedented access to our natural environment. The technology allows us to draw on a massive library of aerial imagery, so we can better respond to natural emergencies, including access to 20 years of flooding data, so we can prepare for the future by understanding the past. You can even monitor vegetation growth and animal movements, helping us to locate and protect delicate habitats. Digital Twin Victoria doesn't just bring data together, it brings people together. For the first time, government, industry, academia and the community can use the same online platform, boosting productivity and collaboration, meaning better results for everyone. Find out more at land.vic.gov.au. victoria.gov.au.
So, despite the obvious spin that this is a government platform and they're trying to promote the vision of what it's going to be, this is a work in progress, and they're putting forward an aspirational aspect of it. The key components that are there, we're looking at collated data sets, with some timescale in there for historical reference. We've got live data feeds, we've got infrastructure projects tipping into it, and we've got planning data integrated as part of their system. And this iteration follows the lead of a number of other digital twins in Australia. A lot of them have been based on some key technology developed within CSIRO in a group of Data 61. The Terrier.js platform is a front-end interface that's being used and will be deployed on this one as well. It's been used for the New South Wales and Queensland digital twin initiatives and the National Map open data platform. So it's worth flagging and maybe even taking a look at that one as a starting point for digital twins, because it is a significant component to a number of key web map-based platforms, and it's able to integrate and show a lot of those intrinsic data systems that are already wanted from those platforms. The next example we wanted to show was how this sort of rich spatial data can be used for some of the event planning type scenarios. With COVID being a reality from the last couple of years, there were some events that required, when restrictions were easing, the promotion of outdoor dining experiences. And what we were looking at is, how can we support this activity of people and, councils and communities figuring out how to redeploy some of their spaces and put forward proposals that might be applicable or land well with approvals for the amount of space and outdoor utilisation. And what these videos are showing is some realisation of that activity, where the virtual model, the photogrammetry digital model, is then combined with a spatial tool to let you place down assets and then go through and plan and show what the potential use of an additional space might be. And so this then can scale up to larger scale events, stadium-wise, even larger scale sort of security exercises like the largest summits that we had pre-COVID in different events. And it's a good idea for that type of event planning or that scenario planning. A great way to communicate, and once you've got this rich data built up inside a digital twin, being able to grab chunks of it, take it out, do an exercise and bring it back in as a stable data set inside that platform is a great way to utilise and build on that. One of the other benefits of digital twin is they allowed us to have ready access to that rich data. And in this example, we've got some work that we did for the City of Melbourne, where they have been wanting to look at urban heat mapping and what impact rooftop gardens can have on reducing some of that heat island effect. So this video shows work that was undertaken where we have done some analysis over the existing built form and categorised the areas available for vegetation across rooftops within Melbourne. And because we've got this rich data again, and we've got some other information about sun and other environmental factors, we're able to then calculate the areas, we're able to populate those with vegetation, we're able to show what the impact visually of that is going to be, and then even extend that further out to show potentially what a future vision could be if we stay on track and if we sort of stretch to reach targets. And this is another sort of example of, how can this rich data suit the purpose of taking from a digital twin and returning meaningful information back to it. The results of this can be fed back into other studies and looked at for other projections for heat island effect and other livability aspects of the CBD within Melbourne. And the idea is that all of this information should be able to be returned back to a digital twin platform, and as the digital twin Victoria gets built up, that will be the exercise that's undertaken. The next video that I wanted to show is showcasing a different type of example where a more custom platform has been built. This is using a games engine technology, and this is a system they've dubbed the Ltouch system. So that it's interface is designed for really being accessible. It's almost like a kiosk-style application as opposed to more of a geospatial or a databasey type application. But it shows how rich city information can be viewed in situ. So we've got, this ability to change the time of day, but we can also look at any of the other key aspects of these key pieces of infrastructure that are mapped out. We'll move on in the video to show some of the other overlays of information that are available. So we've got the different building types which can be filtered and visualised through. Within that, we can identify and highlight any of the key building features from linked databases. If you're looking for key assets within the city, those are things that can be drawn from a database and pulled through. And the idea is that the very excellent visual quality and the deep integration of the data means that you have a platform that is a little bit built for purpose, but still very accessible and gives a good user experience. So this is another type, I guess, of digital twin that we're seeing in the market. These are more bespoke products which are built for purpose. There's another great example produced by Build Media in Wellington, which has been quite popular on social media. And again, it's about figuring out what the users want to be able to do with these platforms, and then coding all of those things in and linking them into the right data sources. But perhaps these examples are a little bit more of a bookended type interface and platform. They're not quite as built for flexibility around a common data environment. So just conscious of time, I'll probably wrap up there. In summary, spatial digital twins are great at consolidating disparate data sets and improving accessibility, giving you great visibility to the wealth of information that we all know exists for our locations that we live and we work in. But a lot of the time that hasn't been brought together and accumulated into a very accessible platform that we can all work from. They allow for integration of live data feeds for real-time information. They incorporate different aspects of planning and infrastructure, geoscience, utility information, social and economic information, and that makes them very rich tools for us to use in the planning and running of our spaces. They're structured around key foundational data sets that form the basis of reference for all additional layers that sort of get stacked on top. And they allow for more in-depth and informed analysis and interrogation and collaboration. It's really early days in terms of these platforms. Even though we've been talking about them for a number of years, they're still developing, they're still coming to market. I think there's 4 studies and tenders out at the moment across different states in Australia for the next round of investigation into what these platforms look like. So it's safe to say that it's still going to be a bit of a race to see what platforms come to market and how they can best be serving all the different user types that we have. But it's an exciting space and one that we're enjoying working in. Hopefully you get an opportunity to be part of one going forward. Thanks very much for your time today. Any questions?
I'm guessing like this, you see in the Queensland Spatial Imagery project or whatever that group, they invested in some of the MetroMap projects, I believe. Is that data through these platforms that are being explored likely to make its way into the public domain, or do you think it's still going to be, the domain of the subscribers?
Yeah, it's a good question. I think that there's still a bit of negotiation and work to do to figure out how the wider dissemination of those data sets. So MetroMap is a subscription program first and foremost, and then to open that up via a public platform has some implications of sort of cost and that band of subscription being worked on. I don't think that door's closed. I think it's just it comes at a price and the economy of what that is. So the state, still runs its own imagery programs, I think, for that reason. And ways to sort of link those things together, I think, that's a good way to move forward. The currency and the frequency that imagery can be captured now is definitely something that I think a lot of platforms can benefit from. So it's just figuring out how to tie those things together in a good symbiotic way. Yeah.
One question goes around governments. I mean, moving forward and thinking, you have
Yeah, it's almost like the search engine race, you know, of the Web 2.0 movement. I mean, it's a race to make the most successful platform so that you get the critical mass. And I think that the country, the whole federal government is staying out of this as a piece that letting individual states run their own race. And then it's up to councils to decide, you know, where the sweet spot is to integrate either into those larger platforms or to develop some, you know, microsystems or open data platforms maybe to seed and start to flow data through to those. I don't think that we're likely to see a complete, you know, Australia-wide amalgam unless the standards are such that at the state level they can naturally flow up and aggregate. And that's what the interoperability piece is about. You know, the more we can make and build on open standards and open data formats, the better the flow of the information, and then the more power everybody has to utilise that information, you know, at different levels through the organisation.
With this integration of data and easy access to it, what's been done regarding privacy considerations?
Yeah, I think that every single data set that's brought into these platforms has a certain level of security already associated with it. So when we're talking about for instance, you know, property information, or maybe there's additional layers that the state or local governments hold. That information integrated into these platforms, security is one of the big pieces. So, you know, making sure that there are different levels of security and access fundamentally built into the platform to make sure the right information is only available to the right people. Where that line, I think, is not necessarily extending to is a lot of the imagery and photogrammetry data sets where that's viewed as public information. You know, Google's been putting that information out for years already, and we're really more seeing restriction on some of those, the metadata, the stored information, the databases of sort of curated information that are coming from the local governments and the councils. Any other questions? That's great. Thank you very much.